Hello everyone. Today I am going to discuss ionic equilibrium. This video is a continuation of acid-base theory. Last three videos I have discussed three theories of acid and base: Arrhenius theory, Bronsted-Lowry acid-base theory, and Lewis acid-base theory. Today I am going to discuss ionic equilibrium. Before we discuss ionic equilibrium, let's recap the concept of chemical equilibrium. This is a reaction, it's a reversible process. A is reactant, B is product. A to B formation is forward reaction, B to A formation is backward reaction. Initially, concentration of A is highest, concentration of B is 0. As the time changes, concentration of A is decreasing, concentration of B is increasing. Now, at a certain point of time, the concentration of A and B will not change. That time it is called the reaction has reached in chemical equilibrium. That means at chemical equilibrium, rate of forward and backward reaction is equal, and that's why the concentration of A and B are not changing at equilibrium. Remember, in chemical equilibrium, reaction doesn't stop. At both forward and backward reaction continues at equal rate, and that's why it is called dynamic chemical equilibrium. Let's explain ionic equilibrium. Ionic equilibrium is another name of chemical equilibrium when we discuss the equilibrium of weak electrolytes, weak acids, or weak base. Dissociation of weak electrolytes, weak acids, and weak base are nothing but a reversible process. And that's why their dissociation reaches at equilibrium at certain point of time. And this equilibrium is called ionic equilibrium. I think now a question arises in your mind that why only weak electrolytes, acids, or bases can reach in ionic equilibrium? Why not the strong electrolytes? Weak electrolytes or acid or base, they undergo partial dissociation in aqueous medium, and that's why they can reach in ionic equilibrium at certain point of time. One of the example is acetic acid. But when we talk about the strong electrolyte, it completely ionizes in the aqueous medium, like hydrochloric acid, sulfuric acid, nitric acid, sodium chloride, potassium chloride. So complete dissociation means it is an irreversible process, and an irreversible process never can reach to chemical equilibrium or ionic equilibrium. And that's why when we discuss about ionic equilibrium, we only consider weak electrolytes, acids, or bases. If you want to recap your concept of weak acid or weak bases at molecular level, you can watch my recent videos on Arrhenius acid-base theory. I will share the link of that video in the comment section. When we explain ionic equilibrium, we come across a new term which is called degree of dissociation or degree of ionization. Since ionic equilibrium means we are dealing with weak acids, base, or electrolytes, they undergo partial dissociation. So degree of dissociation define the fraction of the total concentration of the electrolyte which is present after the ionization. We can explain the degree of dissociation using an example. Ab is a weak electrolyte it undergoes partial dissociation in aqueous medium and it gives AN plus plus BN minus, and at certain point of time it reaches in equilibrium. Initially, the concentration of AB is C and concentration of products are 0. Let's assume alpha is a degree of dissociation. So at equilibrium, C alpha of AB dissociate and it gives C alpha AN plus and C alpha BN minus. That means, what is the concentration of AB at equilibrium? So at equilibrium, concentration of AB is C minus C alpha. C is the initial concentration and C alpha is dissociated. So that means at equilibrium, the concentration of AB is C minus C alpha. And concentration of AN plus and BN minus are C alpha. Now at equilibrium, K is the Ionic Equilibrium constant. So concentration of product divided by concentration of reactant. From the previous equation we have seen that concentration of products are C alpha. So we have to put this value. And concentration of reactants is C minus C alpha. So we can write it down this equation like that, C into 1 minus alpha. Then rearranging the equation we will be getting that at equilibrium constant or Ionic equilibrium constant K equal to C alpha squared divided by 1 minus alpha. For weak electrolytes, degree of dissociation means alpha is very small. So 1 minus alpha we can consider is 1. That means K equal to C alpha square. So alpha equal to root K by C. So here you can see the degree of dissociation is equal to square root of Ionic equilibrium constant divided by the concentration of reactant. This equation is known as Oswald Dilution Law. Degree of dissociation depends on two factors, temperature and concentration. Equilibrium constant K depends on temperature. That's why degree of dissociation is also dependent on temperature. From this equation we can see alpha is indirectly proportional to concentration of the electrolyte. If we increase the concentration of the electrolyte, the value of alpha is going to decrease. We also can explain it with the concept of dilution. When we increase dilution, that means concentration is reducing, ionization constant is increasing. Concept of degree of dissociation also can be applied to weak acid and bases. Acetic acid partially dissociates into water and it gives acetate ions and H plus ions. So equilibrium constant of this particular reaction is concentration of products divided by concentration of reactants. The concentration of a pure liquid or solid is taken as 1. So we can write the equilibrium constant like that. K into concentration of H2 means it's a new constant that is called K. So K is the acid dissociation constant. So K equal to concentration of products divided by concentration of acetic acid. If K value increasing, that means H plus value is also increasing. It indicates acid gets stronger. From acid dissociation constant, we can derive a new equation. Let's see which new equation we can derive from this equation. Now this is the equation Ka equal to concentration of product divided by concentration of reactant. If we take log on both the sides, we will be getting log K equal to log acetate ion plus log H plus minus log concentration of acetic acid. Now take negative sign on both the sides. So we are getting this equation. Minus log K means pKa, minus log H plus means pH. So pK equal to pH plus log acetic acid minus log acetate ion. So pK equal to pH plus log acetic acid, concentration of acetic acid divided by concentration of acetate ion. Now according to Bronsted-Lowry acid-base theory, acetic acid dissociate into acetate ion and H plus. So acetate ion is a conjugate base of the acid. So we can rewrite this equation like this, that pK equal to pH plus log concentration of acid divided by concentration of conjugate base. Now if we rearrange this equation with respect to pH, pH will be in the left hand side, then we can get a equation pH equal to pK plus log concentration of conjugate base divided by concentration of acid. This equation is known as Henderson equation. Now same reaction and equation we can apply for weak base concept. So can derive the Henderson equation for the weak base. So this is the equation of the weak base, POH equal to pKb plus log concentration of conjugate acid divided by concentration of base. So here we have taken an example of ammonium hydroxide. Ammonium hydroxide is a weak base. When it dissociates, it gives a conjugate acid, that is NH4 plus OH minus. Let's summarize the key points, whatever we have learned from this video. Ionic equilibrium is applicable for weak electrolytes, acid and bases. Ionic equilibrium is another name of chemical equilibrium. Ionic equilibrium constant is connected with degree of dissociation of weak acids, base or electrolytes and the concentration of the reactants, and it is called Oswald Dilution Law. From ionic equilibrium constant of weak acid and base, we can derive a new equation which is called Henderson equation. In Henderson equation, pH or POH is connected with the acid dissociation constant and base dissociation constant respectively. I hope this video will be helpful for your study and it will clarify your doubts in ionic equilibrium. If you find this video is helpful, then you can subscribe my channel Chemistry Affinity. Share it with your friends. If you have any questions related to chemistry, you can send me a mail chemistry.affinity@gmail.com. Thank you for watching this video.